it goes like this. Okay, our today's topic is work and the first law of thermodynamics. It can be asked in a 2-mark short. They'll say, okay, explain the relationship between work and the first law of thermodynamics. Okay, first of all, in chemistry there are two types of work involved. It is necessary to have information about work before we understand the application of the first law of thermodynamics. Okay, when can we say a work is done? Suppose, okay, if there is a wall over here and if I apply pressure over here, suppose मैं यहाँ पे pressure लगाता हूँ, do you think so the work is done? See, in this wall, if I applying pressure, what do you say? Is there any work done? No. Why? Because once you apply force, there has to be some displacement. See, will you say is this work done or not? It is done. Correct or not? When you apply force, okay, there has to be some displacement. If there is no displacement, then no work is done. Okay, and if the displacement of the object is there in the same direction where we are applying the force, then the work is done. So when can we say the work is done? When on any substance force is applied at a point where it is applicable and the point moves in the direction of the force applied, then we can say work is done. Otherwise not. Correct? Are you following me? What is work done? In chemistry there are two types of work. One is electrical work and second is mechanical work. Now normally electrical work involves ions in the system. Like we know, okay, in car there is a battery is there, chemical reaction takes place, because of that electrical work is done. So okay, in chemistry when due to some chemical reaction electrical work is done, it normally involves ions. It normally involves ion. In this chapter we are not going to study this type of work. We are not going to study electrical work. Chemistry involves two types of work. One is electrical work and second is mechanical work. But we are not going to study about electrical work. We are going to study about electrical work. We are going to study in detail in semester 3, next semester. There is a chapter दिया गया हमको जिसके बारे में हमको पढ़ाई करना है. Right now we are going to study about the mechanical work. What do I mean by the mechanical work? Okay, if you do remember, last time I had given you one example. Suppose one container contains a gaseous substance over here, and suppose if we apply pressure over here and by this plate, if you apply pressure, so definitely this gaseous system will be condensed. Okay, gas condense हो जाएगा and some work is done on the system. So this type of work where pressure is involved and due to pressure volume is changed, then it is called mechanical work. Mechanical work normally involves pressure and volume. Acha, by the way, but the mechanical work where pressure is applied, it is only used for those things which possesses gaseous state. Pressure and volume work is normally related to the system which has gaseous state. गैस के लिए ही प्रेशर काम का है. सॉलिड आर इनकम्प्रेसिबल बाय प्रेशर. सॉलिड दबते नहीं है. इवन लिक्विड आर इनकम्प्रेसिबल. They say if we increase 1000 times pressure on liquid, then the change in volume is only 4%. बहुत ही कम चेंज होता है लिक्विड का भी. So liquid are also incompressible. जब हम मैकेनिकल वर्क की बात करेंगे, मैकेनिकल वर्क is important during which the reaction there is a change in volume in the presence of external pressure, but that is applicable only for those systems which possesses gaseous state, neither for liquid nor for solid. Is that fine? Are you able to understand me? What am I trying to explain you? For them, mainly mechanical work is more important. Okay. One thing we need to understand, as I was explaining you over here. Okay, here when I applied pressure, what observation do we see? Is volume increasing or decreasing? It is decreasing. See, it's very easy to understand. Once if we apply pressure on the system, then the volume decreases. Volume decreases. Whenever the work is done on the system, always remember volume decreases. And suppose if the system is doing the work, then volume will increase. At that time, okay, ये जो है हमारा, okay, it will move out. If the work is done by the system, volume increases, and if the work is done on the system, volume decreases. Is that understood? What am I trying to explain you? ये काफी important है. आपकी बुक में आप भी अंडरलाइन करोगे मेरे साथ. Okay. What are we going to underline? If the volume of this type of system increases during reaction, then work is done by the system. And if the volume decreases, then the work is done on the system. See, what are the points I taught you over here? Okay, just a minute. See, how many points I taught you? I taught you, we are talking about work and the first law of thermodynamics. What are we studying? Work and the first law of thermodynamics. Then first point we had seen, what do you mean by work done? If there is a force applied and there is a movement in that same direction, then the work is done. There are two types of work: electrical work, mechanical work. Electrical work normally involves ions. Okay, we do not want to study about ions in this semester. And what is mechanical work? When you apply pressure or in the presence of the pressure, there is a change in volume, then we call mechanical work is done. We have to be careful. Mechanical work is always applicable for gaseous system. It does not involve solid or liquid. And the one more point which we have learned, if the work is done on the system, then the volume decreases, and if the work is done by the system, then the volume increases. We had learned that point. Suppose initial volume of any system is V1. Suppose initial volume of one system is V1 and the final volume is V2, and the external pressure P is applied on the system at that time. Then the work done on the system due to the change in volume can be given by following equation. W equals to P V2 minus V1. क्या लेंगे हम? W equals to P into change in volume, delta V. That is called work done. However, ध्यान से मुझे ये चीज बताना. Okay, in this system, if work is done on the system, what will happen? Volume increases or decreases? Volume decreases. Okay, when the work is done on system, volume decreases. Correct or not? Volume decreases. Do I mean by, or do I understand by that is that that V2 will be less than the V1? Volume जब decrease होगा, then final volume V2 will be less than the initial volume V1. Right or wrong? Okay, if final volume V2 is less than the initial volume V1, then V2 minus V1 कैसा होगा? Obviously it will be negative. Okay, that means this work will become negative work. Hello? When you do the work on the system, that work is supposed to be positive. That was the first law of thermodynamics. Symbolic form, sorry, the mathematical form says that. एंड यहां पे आपको वर्क डन ऑन द सिस्टम कैसा आ रहा है? नेगेटिव आ रहा है. इट इज सपोज टू बी व्हाट? पॉजिटिव. करेक्ट और नॉट? वेट. ओके, उल्टा देखते हैं. सपोज वर्क इज डन बाय द सिस्टम, ये वाला नहीं, ये उल्टा करेगा. देन फाइनल वॉल्यूम V2 will be greater than final volume V1. Okay, V2 minus V1 will be positive. Hello, work is done by the system, and whenever the work is done by the system, work is supposed to be negative. And यहां पे कैसा वर्क मिल रहा है? जब नेगेटिव होना चाहिए तब पॉजिटिव मिल रहा है, जब पॉजिटिव होना चाहिए तब नेगेटिव मिल रहा है. सो वी नीड टू चेंज दिस इक्वेशन. There is something wrong with this formula. So to match symbolic form of first law, we will take W equals to minus P delta V. We will not take W equals to P delta V. Are you following this? You write in your book this point. See over here. Okay, we are supposed to take W equals to minus P delta V. उन्होंने भी change किया, but they have not explained why they changed it. But they have not explained. First they are saying W equals to P delta V, and suddenly they are saying W equals to minus P delta V. Okay, हमारे जैसे सीधे साधे लोग हैरान हो जाते, कंफ्यूज हो जाते, ये क्या है? कभी W इक्वल्स टू P डेल्टा V, कभी माइनस P डेल्टा V. कोई बात नहीं, आई एम देयर टू हेल्प यू आउट. आर यू फॉलोइंग दिस? जहां जहां पे टेक्स्ट बुक ने ऐसे गलती की है मैं आपको बताऊंगा. हेंस इफ द वर्क डन ड्यूरिंग द रिएक्शन इज ओनली प्रेशर वॉल्यूम टाइप, देन ओके, एंड अगर आप हीट एक्सचेंज कांस्टेंट प्रेशर पे करते हो, देन Q इक्वल्स टू क्या लिखोगे? QP लिखोगे. QP स्टैंड्स फॉर हीट एक्सचेंज एट कांस्टेंट प्रेशर. खाली प्रेशर नहीं, हीट एक्सचेंज एट कांस्टेंट प्रेशर. देन द वर्क डन ऑन द सिस्टम W इक्वल्स टू क्या लेने वाले हो? माइनस P डेल्टा. नाउ डेल्टा U इक्वल्स टू क्या था? Q प्लस W. सो देयरफॉर डेल्टा U इक्वल्स टू क्या लिखोगे? Q माइनस P डेल्टा V. दिस इज द रिलेशनशिप. ये फर्स्ट लॉ था. ये कौन सा था? और ये हमने डाला वर्क का लॉ अंदर डाल दिया. मतलब रिलेशनशिप क्या आ गई? बिटवीन फर्स्ट लॉ एंड वर्क. दैट्स व्हाट दे वांटेड. दैट्स व्हाट दे वांटेड कि वर्क एंड फर्स्ट लॉ के बीच में रिलेशनशिप लेके आओ. तो हमने लेके आया डेल्टा U इक्वल्स टू Q माइनस P डेल्टा V. इज दिस फाइन? यहां तक समझ में आ रहा है? वेट. ओके, जब मैं इंटरनल एनर्जी की डेफिनेशन डिटेल में दिया आपको, उस टाइम पे मैंने आपको बताया था कि भाई डेल्टा U equals to QV, and I said you right now learn like this. I'll explain you why. Now I'll explain you why. Okay, इन जो लोग पहले हमारे साथ लेक्चर अटेंड किया उनको मैं ये सिखा चुका हूं, बराबर? आप लोग बाद में सीखोगे. ओके, नाउ Q ऐसा हो रहा है, मैं सिखा रहा हूं. बट इफ देर इज नो चेंज इन द वॉल्यूम, सपोज हमने हीट एक्सचेंज की, हमने प्रेशर भी लगाया, बट देर इज नो एक्सचेंज ऑफ वॉल्यूम. वॉल्यूम में कोई चेंज हो ही नहीं रहा. दैट मीन्स डेल्टा V इक्वल्स टू क्या है? 0. तो ये पार्ट क्या हो जाएगा? 0 हो जाएगा. देन डेल्टा U इक्वल्स टू क्या मिलेगा? Q. बट ऐसी हीट को हम डेल्टा U इक्वल्स टू ओनली Q, बट ऐसी हीट को हम बोलते हैं हीट एक्सचेंज एट कांस्टेंट वॉल्यूम, बिकॉज देयर वाज नो हीट एक्सचेंज, सॉरी देयर वाज नो वॉल्यूम चेंज. दैट्स व्हाई डेल्टा U इक्वल्स टू क्या मिला आपको? QV. Thus in the reaction occurring at constant volume, याद रखना, if any reaction occurring at constant volume, the value of change in internal energy of the system is equal to the heat received by the system or heat lost by the system at constant volume. Any reaction occurring at constant volume, then the change in internal energy is always equal to heat exchanged. Heat exchange. Is that fine? Let me stop it.